Hello everyone and welcome to the lecture on Amazon Keyspaces for Apache Cassandra. So this lecture will contain all those topics. What is Amazon Keyspaces? Traditional Apache Cassandra deployment, how it works, Cassandra data model, functional differences between Amazon Keyspaces versus Apache Cassandra, consistency level support, performance comparison, migrating from Cassandra to Amazon Keyspaces, and Amazon Keyspaces features. So what is Amazon Keyspaces? Amazon Keyspaces is a managed database service that is scalable and highly available and is compatible with Apache Cassandra. Amazon Keyspaces is serverless, which means that the user does not have to manage servers, install any software, or perform any maintenance. Users pay only for the resources they use, and the service automatically scales tables up and down in response to application traffic, which makes it cost-effective. Users can run existing Cassandra workload on AWS by using the same Cassandra application code and developer tools that they use today. So, traditional Apache Cassandra deployment. Traditional Apache Cassandra's architecture requires significant hands-on management through its cluster-based deployment, where the responsibility lies with the users to manage multiple nodes, making it a more complex system requiring careful attention and expertise in node management and configuration. Client access to Cassandra is designed to be straightforward and familiar, with applications connecting to any single node in the cluster and using CKAD, which is Cassandra Query Language, which is a SQL-like language that provides a comfortable interface for developers accustomed to relational databases. Even though Cassandra itself operates on non-relational principles, this design choice significantly reduces the learning curve for teams transitioning from traditional relational databases. So how it works? Architecture-wise, in contrast to traditional Apache Cassandra, which is deployed in a cluster with nodes that users are responsible for managing, Amazon Keyspaces removes the administrative overhead of managing Cassandra by being serverless, so users do not need to provision, patch, or manage servers. Data storage. Amazon Keyspaces stores data in partitions, which are allocations of storage for a table backed by SSDs. Data is automatically replicated across multiple availability zones within an AWS region for durability and high availability. Amazon Keyspaces handles partition management and automatically provisions additional partitions as throughput or storage needs grow. Amazon Keyspaces stores 3 copies of data in multiple availability zones. Access. Amazon Keyspaces implements the Apache Cassandra Query Language SQL API. Client programs access Amazon Keyspaces by connecting to a predetermined endpoint and issuing SQL statements. Users can update their application by updating their Cassandra driver or CQLSH configuration to point to the Amazon Keyspaces service endpoint. All client connections require Transport Layer Security (TLS). Scalability. Amazon Keyspaces is designed to handle massive workloads and scale seamlessly to accommodate growing data volumes and traffic. Tables can be easily scaled up or down based on demand. The service offers low latency data access, and its distributed architecture ensures read and write operations are distributed across multiple nodes, delivering consistent single-digit millisecond response times even at high request rates. Amazon Keyspaces also offers 2 throughput capacity modes for reads and writes. One is on demand and second is provision, with the ability to change the capacity mode of a table once per day. Cassandra data model. So first is about primary key. In Cassandra, data is stored as a key value pair. Every Cassandra table must have a primary key, which serves as the unique identifier for each row in the table. The primary key is a composite of a required partition key and optional clustering columns. The data that makes up the primary key must be unique across all the records in a table. Partition key. The partition key portion of the primary key is required and determines which partition of your cluster the data is stored in. The partition key can be a single column or it can be a compound value composed of 2 or more columns. You would use a compound partition key if a single column partition key would result in a single partition or a very few partitions having most of the data and thus bearing the majority of the disk input-output operations. Clustering column. The optional clustering column portion of your primary key determines how the data is clustered and sorted within each partition. If you include a clustering column in your primary key, the clustering column can have one or more columns. If there are multiple columns in the clustering column, the sorting order is determined by the order that the columns are listed in the clustering column from left to right. Partitions. Data is stored in partitions on disk. The number of partitions and how data is distributed across these partitions is determined by the partition key. The definition of partition key significantly impacts query performance. Key value pairs. So Cassandra stores data as key value pairs, which means that each row in a table is accessed using a unique key. The primary key ensures the uniqueness of records, and the partitioning strategy ensures efficient data retrieval. Table design, query first. So there are no joins in Cassandra query language. Therefore, you should design your tables with the shape of your data and how you need to access it for your business use cases. This might result in denormalization with duplicated data. You should design each of your tables specifically for a particular access pattern. Functional differences between Amazon Keyspaces and Cassandra. First one, serverless architecture. So Keyspaces is serverless and there are no clusters, no host or JVMs to configure. Unlike Apache Cassandra, which requires manual configuration of these elements. Asynchronous operations. Amazon Keyspaces perform data definition language (DDL) operations such as creating and deleting keyspaces, tables and types asynchronously. You can monitor the creation status of these resources. Cluster configuration. Because it is serverless, Amazon Keyspaces does not require configuration of settings like compaction, compression, caching, garbage collection, and bloom filtering. These settings are applicable to Apache Cassandra and are ignored if specified in Amazon Keyspaces. Connections. Existing Cassandra drivers can be used to communicate with Amazon Keyspaces, but drivers need to be configured differently. Amazon Keyspaces supports up to 3000 CQL queries per TCP connection per second, but there is no limit on the number of connections a driver can establish. Data plane operations. Amazon Keyspaces supports all commonly used Cassandra data plane operations such as creating keyspaces and tables, reading data and writing data. System tables. Amazon Keyspaces populates the system tables that are required by Apache 2.0 open source Cassandra drivers. The system tables that are visible to a client contain information that is unique to the authenticated user and are fully controlled by Amazon Keyspaces and are read-only. Consistency levels. Amazon Keyspaces replicates all write operations 3 times across multiple availability zones for durability and high availability. Writes are durably stored before they are acknowledged using the local quorum consistency level. Amazon Keyspaces does not support the consistency level of each quorum, all, 2, 3, any, serial or local serial. Range deletes. With Amazon Keyspaces, you can specify a range to be a subset of the contiguous rows within a partition key by using relational operators, or by including the partition key and omitting one or more clustering columns. And you can delete up to 1000 rows within a range in a single operation. Range deletes are not isolated, and individual row deletions are visible to other operations while a range delete is in process. So consistency level support, I just want to make it very obvious. So Amazon Keyspaces only support local quorum, and others are not supported, and Apache Cassandra supports all the other, which are each quorum, all 2, 3, any serial and local serial. Performance comparison. So just to reiterate, so configuration wise, we have seen serverless, scaling is automatic and fully managed, but Cassandra, everything is manual and self-managed. So now migrating, if you want to migrate from Cassandra to Amazon Keyspaces, so this is a rough flowchart or guideline how to approach this problem. So first you review your migration concepts. So begin by reviewing the fundamental concepts and best practices for migrating to Amazon Keyspaces. Understanding the differences between the two systems is important for successful migration. Step 2. Assess functional compatibility. Carefully evaluate the functional compatibility between your existing Apache Cassandra setup and Amazon Keyspaces. While Amazon Keyspaces supports many common operations, there might be some differences to address. Gather table metrics. Prior to migration, gather comprehensive metrics about your Cassandra tables. This includes details like table names, their descriptions, average read and write operations per second, the total volume of data, and the average and maximum row sizes. These metrics are crucial for estimating cost and planning capacity. Estimate pricing. Use the gathered table metrics to estimate the cost of your workload on Amazon Keyspaces, taking into account throughput, storage, and other relevant factors. Select a migration strategy. Determine the most suitable migration strategy for your needs. This could be an online, offline, or hybrid approach. Online migration is suitable for applications that require continuous availability and read after write consistency. Offline migration is a simpler method where data is migrated during a planned downtime. Hybrid migration offers a near real-time migration without guaranteeing read after write consistency. Online migration steps. So if you choose the online migration strategy, follow these steps. Implement dual writes so that new data is written to both your existing Cassandra cluster and Amazon Keyspaces simultaneously. Upload the historical data to Amazon Keyspaces. The application needs to remain available during this upload. Validate data consistency between the two databases during the whole migration process. Migrate the application to use Amazon Keyspaces as its primary database. Begin a canary deployment where the migration is gradually rolled out, increasing traffic to Amazon Keyspaces in small increments. Offline migration steps. So if you choose offline migration, use AWS Glue to export data from Cassandra in Parquet format and store it in an Amazon S3 bucket. Create an AWS Glue job to import data from S3 bucket to your Amazon Keyspaces tables. Hybrid migration steps. So if you choose a hybrid migration, use SQL Replicator, an open source utility for near real-time migration of data. Consider using the Change Data Capture CDC to replicate ongoing changes to your Amazon Keyspaces tables. Choose migration tools. Select the appropriate tool for your migrations, and options include SQL SH copy from, which is good for smaller datasets and test. DS Bulk, which provides more robust import capabilities. AWS Glue, an ETL tool that is great for large migrations. SQL Replicator, which helps with near real-time data replication. And Apache Spark connector that you can use to write data to Amazon Keyspaces. Prioritize data migration. You may want to prioritize what data you migrate first based on how simple it is to migrate or how essential it is to the application. For instance, start with the data that does not change often, data from batch jobs, data that is not used during off hours, or data from internal applications. Decommissioning Cassandra. Once the migration is complete and data consistency is validated, plan to decommission the original Cassandra cluster based on your data retention policies. So last, I will just cover all the Keyspaces features. So first one, time to live. Amazon Keyspaces expires data from tables automatically based on the time to live value you set. And you should learn how to configure TTL and how to use it in your tables. Point in time recovery. You can protect your Amazon Keyspaces tables from accidental write or delete operations by creating continuous backups of your table data. And you should learn how to configure PITR, point in time recovery, on your tables, and how to restore a table to a specific point in time, or how to restore a table that has been accidentally deleted. Working with multi-region tables. Multi-region tables in Amazon Keyspaces must have write throughput capacity configured in either on-demand or provisioned capacity mode with auto-scaling. Plan the throughput capacity needs by estimating the required write capacity units WCUs for each region, and provision the sum of writes from all regions to ensure sufficient capacity for the replicated writes. Static columns. Amazon Keyspaces handles static columns differently from regular columns. And you should know how to calculate the encoded size of static columns metering. So there is some metering around read and write operations on static data, and guidelines available in the document. So you can check out this particular feature. Queries and pagination. Amazon Keyspaces supports advanced querying capabilities like using the in operator with select statements, ordering results with order by, and automatic pagination of large result sets. Partitioners. Amazon Keyspaces provides 3 partitioners: Murmur 3 partitioner, which is the default, a random partitioner, and the default partitioner. You can change the partitioner per region at the account level using AWS Management Console or Cassandra query language. Client-side timestamps. Client-side timestamps are Cassandra-compatible timestamps that Amazon Keyspaces persist for each cell in your table. Use client-side timestamps for conflict resolution and to let your client application determine the order of writes. User-defined types, UDTs. With user-defined types, you can define data structures in your applications that represent real-world data hierarchies. Tagging resources. You can label Amazon Keyspaces resources like Keyspaces and tables using tags. Tags help categorize resources, enable cost tracking, and let you configure access control based on tags. AWS CloudFormation templates. AWS CloudFormation helps you model and set up your Amazon Keyspaces and tables so that you can spend less time creating and managing your resources and infrastructure. And that's all. Thanks for watching.